Hello everyone, welcome to this new video. And in this video today we will be discussing about a new kind of LLM which are currently emerging in the LLM market and seems to be quite promising. And one such LLM is Bonsai LLM, which is a one-bit LLM from a small startup, I think located in US. And this specific LLM is very much interesting because in previous months, I think in February this was released, and until now I have also tested it already. And in my opinion, this was one of the best one-bit LLM I have so far tested. And I tested it on my Raspberry Pi, which is having 4 GB of normal RAM, and it's a Raspberry Pi 5, and it ran quite good. So, in my opinion, this model is quite intelligent. Just to give a little, I would say, information what one-bit LLM actually mean. So one-bit LLM are actually large language models in which weights are usually represented by one bit per parameter. So normally, for all the LLMs that we have currently in the market, for example, Claude, Gemini, or Anthropic OpenAI, or even open source models like Quen, most of the LLMs are coming by default in 16-bit parameter or like 32-bit parameter. So, but this specific model from Bonsai is a one-bit parameter, and one-bit parameter, yeah, it means that uh, in this model weights are often restricted to values like, for example, +1 or -1. But in float, in like 16-bit floating point or like 32-bit floating point LLMs, these are like represented usually by decimal points. That's why the layers, the neural network layers for each of the model in 32-bit or 16-bit takes much more energy and much more memory in the RAM or VRAM, and that's why it's a bit slower. And here in one-bit LLM, in the memory, it just, for example, in the neural network layers, the model bits are represented by one or plus minus one. That's why it takes much less memory because there are no decimal weights, decimal for the weights, and that is why this kind of models run very faster compared to the other LLMs. And in this video, we will be talking about this LLM. I will be trying to install it on the Raspberry Pi, and we will do some test. And here, if I open the page from Prism ML, here we can see this Bonsai one-bit LLM is 14% less memory, so it consumes 14% less memory compared to other LLMs. It's 8 times faster and takes 5 times less energy. And here they have like different kind of models. So one is like ternary bonsai model, which use like +, -1 and 0 as weights. And like this is there is also like image model. I will make a separate video to generate image using this model. So if we check at the benchmark of this model, so here you can see one bit bonsai 8 billion model. It's having, for example, intelligent density per GB is like the highest compared to other open source model. And if I go back here in the intelligent density compared, and if I go in this table where it is being compared to other models, so you can see Quen 3 and like Mistral 3 and like other LLMs which are quite huge in size. So like this Quen 3 8 billion is like 16 GB in size. These are the model weights, and we can see Bonsai 8 billion one-bit model is like just 1.15 GB, which is comparatively very small. Like it's like 16 times, 15 times smaller than other LLMs in the list. And according to them, the performance, according to like Bonsai, performance of the LLM is quite comparable with the bigger LLMs. So they claim that their one-bit LLM is actually on par with like high-end like open source models, and that's what we are going to test in this video. So I will put this link in the description, so you can also go on the page and like read everything what one bit LLMs actually are. So I will get into the video, and yeah, let's start it. So there are a few ways how we can install this model. So one of the main ways, I would say one of the easier ways, is to use like a LLM engine. Normally I use Llama because it's quite easy, and for people who are getting into AI, who are like new in this AI segment, they find it easy to use Llama. But I would say preferably VLLM or llama-cpp is much better choice compared to ollama, because then you have more control over the LLM. And unfortunately, we will be using this model with llama-cpp in this video. So I am here on the Hugging Face. For the people who don't know Hugging Face, so Hugging Face is a website which is having a lot of like models and like spaces and like a lot of different kind of things. So you can find a lot of LLMs here, open sourced, and here you can find the official Prism ML Bonsai 8 Hugging Face. So I can also put this link in the description, so you can just go and download the model from here. And if you go here in the files and versions, so you will find here Bonsai 8 billion Q1 0 gguf and this file. So you can download either of these files. So both of them are 4-bit. I will be downloading this file, for example, and I have also made like a small cheat sheet where I have like put all the commands already. So I will also put this all the commands in the description, so you can use them as you would like. So if I go in the background and then let's do with the installation of everything. So here I have in one of the windows I have SSH'd to my Raspberry Pi 5, and if I show you my how much RAM, for example, I'm having. So here you can see I'm having like 3.89 GB of RAM. This is like the Raspberry Pi 5 RAM, and I also have made a swap of 6 GBs because I'm testing a lot of LLMs on this Raspberry Pi lately. And here you can see I have like 4 cores. So this is what we will be using in this video to run our LLM. And if I show you which other LLMs I have in my PC, in my Raspberry Pi, so you can see these are like different LLMs that I'm having right now, but these are uh, for ollama. But in this video we will be using llama-cpp. So here this is the first command which you can use to create a swap RAM for 6 GB or whatever GB you would like. So for example, if you have a Raspberry Pi or an old PC which only have, let's say, 2 GB of RAM, then you can like increase the number here from 6G to whatever number you would like to have for the swap RAM. I would not recommend creating a very big swap RAM, because swap RAM is generally created on the hard disk or like SSD or like SD card, for example, if you're having on your Raspberry Pi. So don't create like 10 GB of or like 12 GB of swap RAM, because when you create it as a RAM, as a swap RAM, it uses the RAM very frequently, and like a lot of read and write operations on the swap RAM can damage your SSD or SD card. So I would say keep it like maximum until like 6 GB. And so here this is the command to make the swap RAM. I have already created it, so I will not create again. But here in this second command, I will just go and check if I have VLLM already or not. I don't remember if I have not. So this command will check, and if not, then it will also install. So I have here created two different windows. So one is here for just the stop, and this is another window where I will be doing all the commands. So let's just copy the command and paste it here. So here you can see it was not installed already, so it's starting to install it now, and it would take some time. In the meantime, what I can also do is I can also like install, like I would say, download the Bonsai 8 billion like model here. So I can just maybe close this one here and then type this command here. So this is going to download the model locally in my Raspberry Pi. So here I have some problems, so okay, I will fix this. So I have installed all the files successfully. So I have the model here installed, and I've also installed the llama-cpp successfully, and let's try to run it. So as you have seen, like in the last video, I had an issue with my command line. Unfortunately that doesn't work. That's why I'm using like SSH in the VS Code now, and here you can see I have split the terminal, and I can just like close it and then restart it again. So here this is the command which I'm going to use to open a chat. This is a command which will answer you regarding this question here, but this command is going to open a chat in llama-cpp, and we are going to interact with Bonsai model. and here I can open htop window, and here we can see how much resources are being used. So if I run this command, it takes few seconds to load the model, and you can see here the model is being loaded now on the memory, and the CPU usage is 0 right now because we have not asked any question from the model. So let's just start by saying hi, and so now you can see directly the usage of the Raspberry Pi CPU is high because model is answering us, and you can see it's not super fast model, but it's quite okay. I think the output tokens of this model is higher as compared to the reading for a user, so I think this is very much usable. So if I tell him can you code for me, so you can see it's going to answer now, and here again the CPU is being used completely. So let's wait until it starts to answer us. So here you can see it's answering us, and keep in mind this is 1.16 GB model. So here if you see here, yeah, 1.16 GB model and 8 billion model, which is quantized for 1 bit. And here you can see it can write codes for you in Python. It can help you debugging code and like so many other tasks. It can write you stories. So this could be used in many ways. One of the ways how this model can be used is using codecs, or for example cloud code. So you can run an instance of llama.cpp, and then you can integrate llama-cpp with the codecs and cloud code, and then it can run infinitely on your Raspberry Pi. So there are a lot of use cases. Unfortunately, I'm not going to make a very long video because I still have a YouTube limitation of 15 minutes, so I can only make video for 15 minutes. And in another video, I'm going to make some games with this model and then do a bit more testing. So this was just the installation part. I hope you like the video, and please subscribe the channel if you like my videos. And if you subscribe to the channel, it gives me motivation to make such videos, and I think in future I'm going to make it better. So please subscribe the channel and like the video. Thank you.